And we're in the last section of chapter 7, the hyperbola. And let's get into it. All right. So they certainly haven't finished this. I mean, this all starts with knowing that the equation, well, I'll find it. I don't know why it's not listed here. The equation of the hyperbola, recognize that. But they're saying analyze hyperbola, find the asymptotes. All right. Won't be doing any word problems. So hyperbola is a collection of all points in a plane. The difference of whose distance is from two fixed points called the foci is constant. So you have the foci and one minus the other is constant. We don't really need to know those applications of those, but yeah, I really wish they'd start on this before they started on the vertices. So to be clear, the vertices don't really help you graph the parabola. What helps you graph the parabola is this equation right here. And we have a new formula that we didn't have for the ellipse. It's a new formula, and I'll explain why, but the major reason is with the ellipse, C was always the smallest, the smallest value, or not the largest, but it was always the smallest. In this case, C is always the largest one. So in other words, A squared plus B squared, the sum of the other two is equal to C squared. That's always true for the hyperbola. So make sure you have this formula for the hyperbola. Remember, for the ellipse, A was the largest one, so the other two added up to A. Now, this time, C is the largest value. Transverse axis is important to us. This is what it's going to look like. All right. So if you start with X, so that has nothing to do with size, just the letter X. If you start with the letter X, you're going to be, X becomes we call the transverse axis, where you have the curvature here, and the curvature wrapping around and intersecting the x-axis. This graph, if I wanted this graph to cross the y-axis, I would have had to put y first and subtracted the other one. So the one that essentially has this invisible plus sign, that's the transverse axis. The points here and here are visible just from knowing what A is. And then B is not really pictured in this illustration or the next couple, so I have a little trouble with that. That's kind of what I was saying. I think the author should have started with how to graph this and then jumped into all the ideas of the focus. So let's find an example where we do actually graph an equation. Guess we have to start with example 2. All right, here is the equation. If that had been a plus, this would have been an ellipse. But no, it's a minus, so it's a hyperbola. We know plenty about this already. But how do you graph it? Wow, those are huge. Okay. This is how big the thing is. All right. Takes up the whole page. What was it again? I can tell by looking at it. It was x squared over 25 minus y squared over 9 equals 1. So along the x-axis, there's 1, 2, 3, 4, 5. And along the y-axis, 5 squared. Along the y-axis, I'm going to travel 3 because 9 is 3 squared. So 1, 2, 3. Now you don't see this, and I'm a little concerned about that. 1, 2, 3. So all I'm doing is using a technique for graphing an ellipse, a hyperbola, by drawing that box. That box is what I get when I see x over 5 squared. I go 5 in each direction on the x-axis. y over 3 squared, I go 3 in each direction on the y-axis. Then what? I'm going to pierce the box through the corners with this line. And either my line is off or the author's graph is off, I don't know. Pierce the box through these corners, that line. Once I've done all of that, I see the starting letter is X, so I know that it's not, the vertex is not on the y-axis. If it starts with X, the vertex is on the x-axis. Right here at the edge of the box. So it's here at 5. And then what I want to do, I'm not a fan of that point right there. I see where they got it, but I want to get another color. Should I get the blue? I'll use purple. All right. I want to just follow the asymptote. Vertex, follow the asymptote. Plotting these points, I have the feeling the author's going to ask us to do that later, but it really is important that I go from the vertex and follow the asymptote, because that's kind of the point of all of this is, you know, something like this almost looks like it's turning away from the asymptote. And again, I don't know if it's my illustration or the author's illustration, you know, didn't quite stand up to scrutiny here. But if you just look at the purple thing without anything else, all you have is something that kind of looks like this, and it's like, is that a graph? You know, the x-axis, y-axis, and that. It is, but you really need the asymptote to really, I don't know, drive the point home that of what shape this really should be. All right. Now, this wouldn't be college algebra without them asking you to find the focus or the foci. What is that? How do I find that? Well, I take these two and just add them together. It's, remember, a squared is 25. A squared plus b squared equals c squared. So a squared is 25, b squared is 9. That's equal to c squared. So c squared is 34. So if c squared is 34, c is the square root of 34. And so I go the square root of 34. So that one might not be terribly obvious. Let me get a calculator and run through that. So if I take 34, take the square root of that, there it is, I get 5.83. So 5.8 is a little less than 6. Yep, 5.8. I go 5.8 this way, a little less than 6. And that's the focus. Now the focus didn't really help me graph this, but they did ask for the focus. All right, let me clean this up a little bit, my eraser here, because I want to talk about what else we do. So we'll go back to the author's drawing here. And the author seems to randomly say, let's plot one random point. No, it's not random at all. The author plotted the two endpoints of the lattice rectum. The lattice rectum isn't as helpful here as it was for the parabola in section 7.2. All right. But clearly the idea is just in the author's head, hey, let's plug in rad 34 and see what happens. And the author said, you know, if you put in square root of 34, you get 9/5. So 9/5. The graph wouldn't have hurt if you had put in 6 or 7 or 8. Whatever number you wanted to put in would be fine. Or at least the way the author did it, because the author didn't really mention the lattice rectum again in this section. But the idea is, if you have these infinitely open graphs, how do you measure how wide it is if it's infinity? Well, you measure it through the focus, and that is a common practice. The other just makes it sound kind of random. All right, so what does the author do on this? Other than not just jump in and start graphing. It's off-centered, but if I went 5 to the left, 5 to the right, if I go 3 up and 3 down, we're really off-centered. And graph this thing. I mean, that's I just want you to be able to graph this like this was Algebra 1. But the author also adds, rightly so, that you know what you're going to need to add to your diagram because of where we are? The foci. So it's not enough just to go 5 and 5. I have to calculate and find the foci. Add these up. I get it. All right. So the other did that without a picture, which is a little awkward. Finding the vertices, the foci. And again, kind of weird how the author never used 3 to find this box. But all right. Okay, what if you start with the letter Y? Well, if you start with the letter Y, your transverse axis is going to be on the y-axis. So the vertex is going to be a comma 0. Or I should say 0 comma a. Yeah. 0 for x, but and then another one down here. The other vertex is right here. Would be 0 minus a. The foci would just be a little outside of that, which we can calculate. All right. So there's a good illustration. I feel like the illustration is a little more complete if I draw this box, this asymptote, this asymptote. And you actually see the graph getting closer and closer to the asymptote. And we already know that this measure from the center to the vertex is A, and in this case, this is B, just the edge of the box. There's no graph here, but just the edge of the box is B minus B. All right, and of course, the distance to the focus is C. So that's what they're giving us. All right. So interesting question. Analyze this. We'll just divide by 9. You divide everything by 9. You get it. Y squared over 1 squared minus x squared over 3 squared. So I know what A is. A is not by size. It's by leading number here. So A is 1. A squared is 1. A is 1. B squared is 9. So that implies B is equal to 3. And that means I can graph this if I come up with my little graph, my little thing. All right, I'm going to go 1, I'm going to go 1, I'm going to go 1, 2, 3. I'm going to go 1, 2, 3. I'm going to draw my rectangle. Draw a little solid here. I think the author uses red, or the website uses red for these things. So, you know, pierce the corners with your asymptotes. So the asymptotes are guidelines you usually draw first. All right, but remember this particular problem started with the letter Y. In other words, plus y squared over 1 squared. So that means the transverse axis is going to be along here, the y-axis. So the vertex is going to go there. The graph is going to sweep by starting at the y-axis. Don't draw anything here. There is no grid here. There is no graph here in between the asymptotes. Now just over here. All right, and then the focus. Well, the focus is going to be square root of 10. Why is it square root of 10? Because c squared equals a squared plus b squared. Remember, I just add those together. I add the 9. I add the 1. I get 10. This is pretty typical, where when you have a hyperbola, well, you always have, you're always going to reach the vertex first, then you're going to reach the focus. So the vertex and then the focus. The vertex first, then the focus, starting out from the center. All right, what are they giving us here? Find an equation of the hyperbola with the following information. Again, I'm going to draw this. I just really hard to imagine doing all of this analysis, even getting the answer without drawing it. So let's draw it. What did they tell us? They told us that this had, did they give us 2 of the foci? Yeah. Oh, no, they gave us, yeah, they did. The vertex 0, positive 3, and then the 2 foci. So they gave us the vertex. This is the one they gave us. And then they gave us the foci. Now, that wasn't enough. They had to give us this foci and this foci because I needed to find the center, because we were going to talk about what happens when these aren't centered. So I shouldn't call it C because C is a measurement, but it's the center. You know what I'm talking about. And now that gives me some symmetry to work with. I know that C, the length, is 4 just by looking at it. And A, the length, is 3. So if that's true, I pick up this other vertex just by kind of flipping this through the center. I have that point. And the other's really bold about graphing it already, but you know what I would do? I would substitute what I know. Remember, c squared, c is that measurement. A is this measurement. B squared. 9 plus b squared equals 16. I get b squared equals 7. And that's also true that b is equal to the square root of 7. And that didn't occur here. And the reason why I say I would do that is I would want to find some space to do this just real quickly here. I'll do it really quickly right here. I would want to, take my A, which is, I know is 3, and go 1, 2, 3, 1, 2, 3. Take my B, which I know is the square root of 7, and what is that? Well, it's between 2 and 3. And draw my rectangle. So that's a rectangle that's 3 this way and square root of 7 that way. Yeah, sounds about right. I mean, looks like a square, but all right. Draw my asymptotes. Like I said, I think the website draws asymptotes in red, and the graphs are either in blue or probably either blue or I think it's blue. Website's down right now. I would check. Blue or black. We draw the graphs. All right, so this is the graph I have, and remember this point right here, I found it. It was 0, -3. But without the asymptotes, this is just such a shady graph. I don't really like it. But all right. I mentioned the asymptotes. So what are they? Well, they are specifically y equals b over ax and y equals minus b over ax. That's what you get. Rise over the run. The b over the a remember how I went to this point right there? I don't know. This distance was B, and this the height was A. So the change in, change in y over the change in x is what I should be saying. The change in y over the change in x. So let's make sure we understand. If you start with x, it's the change in y over the change in x. If I start with y, that's going to be flipped. So, all right, real quick, let's look at that. All right, finally, we're getting that whole shape in here. What role B plays and all of this, and the equation of the asymptote. Change in y over the change in x. If you remember, when this had an x here, it was b over a. When the y is there, it's a over b. That's not a typo, so that is important to see that. So now they can start asking us for the equation of the asymptotes. But you know what? I feel like we're way ahead. If you already have this graph, you can see the equation of the asymptote with or without that formula. So, I mean, even reading this is painful to me without a picture first. So, what was the question? Here it is. Y squared over 9 minus x squared over 1. Let's change that 9 to a 3 squared to make it visible. So the letter y means up the y-axis. I'm going to go 1, 2, 3. The letter under the letter x is 1, so I'm just going to go 1 in each direction. And just like the author did here, perfect. Draw the box. Again, I would have drawn that first before I even had tried to answer any questions. And then draw this line. Now I say this is pretty obvious that is y equals 3x because of y equals mx plus b. Well, b is the y-intercept. That's 0. And the slope is the rise over the run, the change in y over the change in x. So change in y is 1, 2, 3. Change in x is 1. Did I use some formula, taking this 3 and dividing by that 1? Maybe. But if you have them drawn, you should know the slope by comparing the points. All right. So we have everything except, I just went straight from here to essentially this picture, except for the vertex. I'm sorry, the foci. What's the focus of this particular problem? Well, you got to find c, which is a squared plus b squared. I shouldn't say that. C squared is a squared plus b squared, which is this 9 plus that 1. So c squared equals 10. C equals the square root of 10. So I'm going to go up the square root of 10 and down the square root of 10. Just to plot those foci if they ask. All right, this will be our last example in this whole thing. Actually, maybe not. We'll see. All right, so they gave us this. I want to divide by 36. So I get x squared over 9, which we secretly think of as 3 squared. And I get y squared over 4, which we think of as 2 squared. And so I know my a, and I know my b. And remember, that means since a is under the x-axis, it means I'm going to go 1, 2, 3, 1, 2, 3. I'm going to go 1, 2, negative 2. Draw my little rectangle. I could draw this. Well, they want us to analyze this, so they do a lot of analyzing before the image, including the asymptotes. Very, 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 it's like working in the dark. Very unusual to do that. Draw it. 3 in each direction, 2 in each direction. Draw the lines. Notice what the rise over the run is. Notice what the slope is. It's y equals 2/3 x because it is. Because you go 1, 2, 1, 2, 3. This would be the change in y, which would be negative over the change in x. So negative 2/3 for that slope. And what I'm saying is once you know the slope, it's just y equals mx plus b. But if b is 0, it's just y equals mx. So you could use the formula others using, I guess, but look at that. No, we don't have any more to say on that one. Yeah, I do have to talk a little bit about. No, I don't think we really have any questions about HK. I tried to delete all of those. So for the hyperbola, anyhow. For the other figures, yeah, but for the hyperbola, tried to avoid questions where it wasn't centered at 0, 0. You know, the center being there. So what I'm saying is, for the hyperbola, it's x squared over a squared plus y squared over b squared equals 1. You shouldn't see any x minus h squared over a squared. Should be minus. Let's fix that. Minus k squared over b squared equals 1. Sometimes I forget what section I'm in. I'm in the section for hyperbolas, so it's minus. All right, but that's all HK does. It just moves the center. So if you have the center here at HK, you're still going to add A to both sides here. You travel B in both directions here. Put it all together. If you start with the letter X, the transverse axis is going to be the parallel to the x-axis. If you start with the letter Y, the transverse axis is parallel to the y-axis. Yeah, I did stop there. So I went through this and chopped off any future examples here because I'm pretty happy with this collection here, and it should get us there. So, you know, be able to find things. I think a lot of them are multiple choice, but be prepared for all of these questions, including the coordinates of the foci and how you find something. Just from knowing A and B, you need to find the foci. Did I go over that on this one? I know I didn't. All right. So this is the problem. However crudely you sketch this from, you know, by hand before you, I don't know, pick the multiple choice question or something, you know that a squared is 9 and b squared is 4. So with the hyperbolas, it's c squared equals a squared plus b squared. So it equals 9 plus 4. So c squared equals 13. So where does this, where do these foci come in this particular problem? Well, they must be at the square root of 13. So that's where that foci is. That's what this one over here would be, minus the square root of 13, comma 0. And the author did lay that out without the picture, but I don't know why anyone would want to do that. All right, use the picture to help you get the image. And then once you calculate the value, you can add it to the image. Or you can add it a little earlier, but you just might not know exactly where it is. All right. So there's that. very general idea. We don't have any homework, as far as I know, questions on this. And if we do, they're very short and brief. As far as the x minus h, y minus k, we just don't develop that particular idea. But all right, that is the last example of this entire chapter that we cover. And we actually covered everything. I don't think there's a 7.5. Just because there aren't that many conic sections. We've covered them all by looking at these sections. All right, so that's the end of chapter 7. If it's not the end of the book's chapter 7, it's the end of it for us. Definitely, look over this, but definitely be able to answer the questions as they are asked on the website. Kind of goes without saying at this point, but know how to do that. All right, that's chapter 7, and this particular video, 7.4.